take a look at 7.4. Okay, 7.4 is more like an algebra section, okay, where you're going to solve equations. Okay, the kind of equations that we're going to solve are going to involve exponents as variables and logarithms. Okay, so keep in mind everything that we know how to do. We can change something from exponential form to log form. Okay, that's what we learned the first day. Or log form to exponential. What else can we do? We can split logs. We can combine logs. We can take exponents and move them in front. And we have the change of base formula. Okay, that's how you type something in that's not base 10 or e. Those are pretty much all the facts that we're going to use to solve these problems. And Algebra 1 skills. So factoring might come up. Quadratic equation might come up, but we'll see. But you do need to know your Algebra 1 pretty good. All right, let's look at that equation. It says 2 log base 5 of x equals log base 5 of 9. Okay, what I want to do, I'll give you a hint, is I want to start on the left-hand side. Does anybody see something I could do there? Even if you're not sure if that would help, is there just something I could do on the left-hand side?
You could put the exponent of the x.
Yeah, so what would happen?
It would become log base 5 of x squared.
Okay. And then the other side stays the same. So she put the 2 back up as an exponent on the argument. That's a rule we learned yesterday. Okay, now equals means what's on the left has to match what's on the right. Is there anything that already matches on the left and right? Yeah, the log base 5 and the log base 5. The only thing that doesn't match yet is you got to make that match that. So we got to find a number for x so that when you plug it in, it comes out to 9. 3. Yeah, x would be 3. If you plug in 3, 3 squared is 9. Then you'd have log base 5, 9 on the left, log base 5, 9 on the right. That's it. That's that problem. They get harder, but that's an easy one. Okay, I'll probably give you one like that on the test too. Any question about what we did there? Okay. If the bases didn't match, like if one was a 5 and one was a 6, now it becomes quite a bit more difficult problem. Okay? But in that kind of problem, I'll keep the bases matching. Right? Okay, here's another problem. The bases are the same, okay, and they will be for most problems. So we have log base 4 of x plus 3 plus log base 4 of 2 minus x equals 1. Okay, on the right-hand side, right now, there's not really a lot I can do. It's just a number, so we'll probably leave that. What about on the left? Anybody see something we can do there that we learned yesterday? Well, what do we have on the left side? We've got what? Addition. Addition of what? What do we?
Aren't you going to separate it to be log base 4 plus log base 4?
Well, is it already separated? The left-hand side? Do we have one logarithm or do we have 2 separate ones? We have 2 right now. It's already separated. Okay? This could not be separated anymore. You can't separate addition. You can only separate multiplication or fraction. Right? So we would want to separate it more. That's going to make it more confusing. Maybe we could reverse it, put it back together. Right? So instead of having 2 logs on the left, we can make it so all we have is 1. how would we recombine these two logs that are being added? So addition goes back to what? Multiplication. Yeah. So you're going to have a single log. And if it's addition, these two arguments must have been multiplied together. So it was x plus 3. And 2 minus x. Okay, any question on that stuff? Because it was addition. I'm going to recombine them together using multiplication. Okay, now how do we do that? How do you multiply these? This is where your algebra 1 starts to come in a little bit.
We use foil.
Yeah, some people call it the FOIL, where you multiply first, outer, inner, and last. Or the distributive property, double distributive property. Either way. So let's do that out. Amy, what's x times 2? Yep, 2x. Okay, Sam, x times negative x?
Negative x squared.
Negative x squared. We're going to write this in a nicer order, but for now, let's just do it like this. 3 times 2 is 6. And Yadira, what's 3 times negative x? Yep, negative 3x. Okay, let's rewrite that in a nicer order. We usually have like x squared first, and then the x term, and then the number. Okay, so let's negative x squared, 2x minus 3x. Okay, combine like terms. It's negative 1x plus 6. Okay, so let's run through the list of things we can do. Can we combine it? We already did that. Are there any exponents outside here to move to front? No. There's no exponents outside the parentheses. Would we want to split it apart again? No. Splitting it's going to make it more complicated. So what's the only thing left I could do with this kind of equation? And this we learned on Monday.
I think the rule that's like, percent something,
Oh, it's not one of the rules from yesterday. No, it's going to go back to what we did Monday. But we are going to see some of those rules, yeah, later on. So that's still good to remember. But what did we do when we had this kind of thing on Monday and we wanted to solve it? It's the only trick we knew. Change it to what? Yeah, what's it called? This is log form. What's the equivalent way to change it? Exponential. Yeah. Get rid of the word log and change it to something that involves an exponent. We don't know if that's going to work, but that's the only thing left we can try. And if it doesn't work, well, then we're stuck. So let's identify our 3 pieces of information. There's one. There's the second one. There's the third one. Okay, Cody, what's my base there?
4.
4. 4 is my base. Paige, what's my exponent? 1. Logarithm always equals the exponent. And the only thing I have left is my argument. And that goes by itself. From this step on, it's algebra. Okay? From here on, it's nothing that I've taught you how to do. The part that I taught you is how you deal with the log and how you get rid of it. Okay? So now we're going to go through and see if we remember how to solve a quadratic from Algebra 1. Hopefully this works out nice. We'll see. First thing I'm going to do out the exponent. Okay? Rather than leave it as 4 to the first power, just do that out. There's something about this right side that I want to deal with in a minute. It has to do with that negative in front of x squared. Okay, anytime you did factoring in Algebra 1 or quadratic formula, we usually try to make this positive. Okay, so that's one thing I want to deal with. Also, I don't like the number that it's equal to. What number do you try to get it equal to when you factor? 0. Yeah. So how could you get that 4 on the other side? Subtract it. Anytime you're solving a quadratic, you always try to get it equal to 0.
Maybe 2.
Yeah, 2. Thank you. Okay, now how could I get rid of that negative? I don't care if anything else has a negative. I just don't want a negative in front of x squared. Whatever you tell me, I'm going to have to do it to all 4 of those. Yeah, multiply each one of them by -1, or divide by -1. Same thing. This is merely a trick that changes the sign of every number. Well, 0 stays the same. Now look what just happened. Negative divide by negative, that's a positive. Okay. Negative divide by negative, that's another positive. And then positive divide by negative, that's a negative. All right, there's a couple ways we can solve a quadratic. One, we could use the quadratic formula. Hopefully we don't have to. Or what's another way? It's a shorter way. Sometimes it involves a little bit of guesswork. You could complete the square. Yep, we could do that. I'm going to stay away from doing it that way. But yes, absolutely, that would work perfect. What else can we do that people don't usually like in Algebra 1? Yeah? I think you said it. Or someone maybe said it. Yeah, factor. Good, factor. Okay, we could factor it. All right, so let's just copy it down up here and see if we can factor it. Anybody tell me what my first 2 terms are going to be in the parentheses? So we're going to have x. Yeah, what did you say the other one was?
X.
Yep. And what about my signs? I have choices of 2 pluses, 2 minuses, or 1 of each.
Plus minus.
Yeah, plus minus. You know that because the constant is negative. Now we need 2 numbers that would multiply to give me 2, and add or subtract to give me 1. 2 and 1. Okay, let's try them in that order. If it doesn't work, we can always try switching it. We got x squared minus x plus 2. Minus x plus 2x is plus x. 2 times -1 is -2. Perfect. Okay, so we factored it. So now our last step is to write our 2 answers. Okay, after you factor it, you can pretty much see what the answers are. Okay? You're multiplying 2 things together and you're getting 0. What's the only way that can happen?
The other side is 0.
Yeah, if one of them is 0, one or both. It's the only way you can multiply 2 things together and get 0 as the answer. What value of x would make the first parenthesis 0? -2. If you plugged in -2, now you'd have -2 plus 2 is 0. -2 minus 1 is -3. And 0 times -3 would be 0. So that one works. And what would be another number that would make that side 0? 1. If you plug in 1, you get 1 plus 2 is 3. 1 minus 1 is 0. 3 times 0 is 0. Okay, so those are our 2 possible solutions. The only thing we have to be careful of, because we're dealing with logs, is that the argument is never negative and the base is never negative. Okay, so let's look at our original problem. We have -2 and 1. Well, the base is already a number, so you don't have to worry about the base being negative. Okay, let's try plugging in -2. If you plug -2 in for x, what's -2 plus 3? 1. Is that positive? Yep, so that's fine. If you plug in -2 for x here, what's 2 minus -2? 4. Is that positive? Yeah. So -2 is fine. That answer works. Let's try 1. Okay, if you plug in 1 plus 3, that's a positive. How about 2 minus, if you plug in 1, is that a positive? Yeah, so 1 also works. Okay, so in this case, both answers work. There's three things that could happen. Both answers could work, just like they did here. It's possible you get one that works and one that doesn't. And it's possible you get both answers don't work. Anybody know what the symbol looks like for that? When you get two answers that don't work, we use a certain symbol. Yeah, if you see this symbol, that means there's no solution. It means you tried both numbers and they both didn't work. Let me give you an example of a number that wouldn't work. 5. If you got x equals 5 as an answer, it wouldn't work. It's okay here. 5 plus 3 is 8. It's not okay here. 2 minus 5, that's a negative number. Okay? So, any questions on what you have to check for? Okay? So, again, most of this problem, really just the first 3 steps. Those were your algebra steps. Trig steps I taught you. After that, it's all algebra. Okay, if we have time, we can try another one like that, maybe where one answer doesn't work, but let's we'll move on for now. Okay, and we already did that. Let's try that one. Log base 3 of x equals 9. Okay, without me giving you any hints, anybody tell me what you think we need to do? Yeah.
Change it to exponential.
Yeah. What would it be as an exponential?
3 to the 9 x.
Done. No problem, done. Okay, 3 to the 9th is a relatively large number, so that's 3 times 3, 9 times. Just leave it like that. It's not huge, but it's pretty big. Okay, any question on that one? Okay, let's try this one. If you look back at Monday, this is kind of what I started the whole unit out with. I gave you problems like this. And I said, what do you think x would be here? And most people got it. And then I said, something like, what do you think x would be there? Most people got that. And then I changed it to something like this. And now it was hard to figure out because 5 isn't a power of 2. But now, hopefully, we know how to figure it out. Before we do it, anybody have a guess what x has to be between? Just two numbers, we know it's got to be between. 2 and 3. 2 to the second power, that's too small. 2 to the third power, that's too big. So whatever we get for an answer, it's going to be between 2 and 3. Okay, how do I find it? Yeah?
Change it to logarithm.
Yeah, change it to log form. Can you tell me what it would be?
Log base of 2
Mhm.
of 5 equals x.
Yes, good. That's the answer. Log base 2 of 5 equals x. Only thing I want to do now is get a decimal for that. Okay. How do I rewrite this so I can type it in on my calculator? Ben?
Log of 5 divided by log of 2.
There's the change of base formula we learned yesterday. Okay, so type it in. Log of 5 divided by log of 2. It's about 2. We said it should be between 2 and 3, and it's about 2.32. So in general, if you've got a very simple equation, there's nothing to combine, there's nothing to split here, just try changing the form, either to exponential or to log. Any question on example 4? Let's try that one. There's not really much different here than the last one. Okay, Sean, what kind of equation is that? Is that exponential or logarithmic?
Exponential.
Yep, it's exponential. Is 24 a power of 3? No. You could try 3 cubed, that's close, but that's 27. Okay, so 3 cubed is a little too big. Okay, so let's rewrite it in log form. Zach, can you tell me what it would be in log form?
It would be log base 3 of 24. 3 of 24 equals x.
Yeah. Good. This time I'll leave you plugging that in yourself. Right, it's log base 3 of 24. If you want the decimal, just use your change of base formula. This one, almost the same as the last two. The only extra step you got to start out with is this. Divide each side by 8. And now you have a number raised to a power that's a variable equals a number. It's exactly the same format as this problem. Number raised to a power equals a number. Solve it the same way. Change it to log form. Okay, so any questions on 4, 5, or 6? Those are all the same type of problem. Yeah, we have one I want to get to that it is hard. It's a hard one. Any questions on that one? All right. This one. All right, so it says 5 to the x minus 2 equals 3 to the 3x plus 2. Okay, what makes it hard is that the bases are different. If you gave me a problem where the bases were the same, it'd be a lot easier. Any thoughts what we can do here? This one's tricky. I might have to give you a hint at the first step. What's something you'd like to be able to do with those exponents? Put them in front, right? Because if you can put them in front, then you don't have exponents anymore. If we can get rid of exponents, it gets easier. Why can't you take those exponents and just put them in front right now? They're not logs. That rule only applies if you have a log. So, one thing we're allowed to do, as long as you do it on both sides, you can take the log. In fact, I'll rewrite it. Take the log of both sides. So do that on the left and on the right. Now, because you took the log of both sides, you can put the exponents in front. Okay, any question what we just did there? Okay, it's kind of a new idea. We've never done that before, but you've done that idea before. You do the same thing to both sides. Okay, you've done it with like addition, subtraction in Algebra 1. We're just doing it with a log. Take the log of both sides. Let's put the exponents in front. Okay, and put the 3x plus 2 in front. Okay, any question up to that step? So looking at that, a lot of people start to get confused because they see the word log. It looks like there's a lot of letters there, and numbers, and confusion. Let me show you something from Algebra 1 that's identical to what you have here. X minus 2, let's use a different number, times the number, equals 3x plus 2 times, I'm just making up a number, 12. If you were going to solve this equation below it, what would be your next step here? Distributive property. Well, that's also going to be your next step here. These two equations, I mean, log 5 is not neat. I'm just trying to show you an equation that looks simpler, but it's actually the same thing. Okay? So your next step would be to distribute. Let's try that. So we're going to distribute log 5. And we're going to distribute log 3. Okay, remember, those are just numbers. If I really wanted, I could find what that number is. Log 5 is just roughly 0.70. Okay, so I'm just distributing 0.70, but I'm going to leave it as the word log, okay, because I don't want to round it off yet. Okay, so I have x times log 5, and I have negative 2 times log 5. Okay, do the same thing on the other side. 3x times log 3 plus 2 times log 3. And now it looks even worse. It looks like we have logs written everywhere. But remember, this entire thing, 2 log 3 and negative 2 log 5, those are just numbers. We could find out what they are right now if we wanted. Or we could get rid of the word log. But I like to round it at the very end. Okay, when you're trying to get x by itself. So what's your next step here? Before you can get x by itself, we can at least get all the x's where? Put them on the same side. Okay, so decide, do you want all your x's on the left or the right? Let's we could put them on the right. Generally, I like to get my final answer x equals the number, but you could have the number equals x. So for this one, I think I'll put them on the left. It's not easier either way. How would we move that term to the other side? Yeah.
Subtract it.
Subtract it. And now it's gone, and put it on the other side. You're not really going to be able to combine these. Okay, there's nothing we can do. We're just going to write it out. So we've decided to put all the x's on the left. We've got to put everything that's not an x on the right. How would we move this negative 2 log 5? Add it. Put it on the other side. Okay, now let's rewrite what we've got. Okay, you got x log 5 minus 3x log 3. I'm just going to write it. I can't do anything with it. On the right, at this point, if I wanted, I could get a number. The whole right-hand side is just a number. But at this point, I don't care what it is. It's 2 times the log of 3 plus 2 log 5. Just add those up. Okay, and we're almost done. So we don't have any exponents left. We got all the x's on the same side. Everything that's not an x is on the other side. We're good. Any questions up to that step? Okay. What do both of these terms have in common besides the word log? They both have an x. What can you do when two things have the same thing in common? Well, we can combine if you have like terms, or we can factor it out. By factoring it out, instead of having it written twice, now we're only going to have it written once. So it's going to make it a little simpler. So we're going to take the x right out. If you take x out of the first part, what are you left with? Just log 5. Just a number. If you take x out of the second part, what are you left with? Negative 3 log 3. Just a number. So now this entire thing is a number we could type in. This entire thing is a number we could type in. And now we're at our last step. If you can figure out how you'd solve this, you're going to solve that the same way. A variable times a number equals a number. What's going to be my next step here? I'm going to do what on each side? Do what? Yeah, we're going to divide. What are you going to divide by? Well, in this problem, you divide by 5, but what about our problem? Yeah, go ahead. What, yeah, you're going to divide each side by what? Yeah, whatever that number is. If we had rounded it off to a decimal, we'd know it, but we don't yet. So just keep it like that. And log 5 minus 3 log 3. And that's the exact answer. What is that as a decimal? Well, I'd just type it in very carefully. Okay, the way I would do it, type in 2 log 3, write down that decimal. Type in 2 log 5, write that down. Log 5 and 3 log 3. Do each one separate. If you try to type all that in at once, I guarantee something's going to go wrong with a parenthesis. And then you could, add up all your decimals and then divide. Okay? But I'm not going to worry about typing it in. Okay, so that's the hard one. Any questions on that? Okay, I know it does seem kind of hard, but really if you remember your distributive property, factoring, that's all it is. Don't get confused because you see the word LOG everywhere. Okay, LOG, it doesn't make it any more complicated. It just makes it look like it's more writing, but it's really not. Okay, any question on that? All right, so the rest we'll finish up with aren't as bad as that one. Okay, this one. What do you notice that's different about this one? The what? The units are the same? The arguments. Okay, yeah, the arguments are the same. What's not the same? The bases. So what would you like to do here that you're not allowed to do? Because of what you just said. Well, yeah, we can't change it to exponential, and generally when we're changing to exponential, we just have something like that. Yeah. Generally, when you're changing to exponential, you're just going to have one thing that's all combined. We've got 2, but we can't combine them. Okay, those can't be combined because the bases are different. Okay, how would you type that into a calculator? If you wanted to, let's say x was a number and I said to plug it in. Because you don't have a base 3 button. So forget about the rest of it for now. Just look at this part right here. What could you change that to that would be the same, but you could type it in on a calculator? Log x over log 3. Look what just happened. Now they have the same base, 10. Can you do the second part for me too? Log x divided by log 4. Look what just happened. Now they have the same base. Everything now has a base of 10. Okay? This would be your first step in solving this equation. Okay, for this one, I'm not gonna finish solving. Okay, because I don't want to get into solving problems with different bases, but I just want to show you that it is very doable as long as you use your change of base formula. Any question on how we just did that? If I ask you to show me your first step in solving a problem like this, you don't have to do the whole thing, just the first step. All right, so problem, logarithmic equation, still solvable by hand, even though we have different bases. Let's look at that one. Okay, it's not a very complicated equation. It just says x plus e to the x equals 2. This one is pretty difficult to solve by hand. Okay? In fact, off the top of my head, I don't know how to solve it by hand. Okay, the problem is I have a variable in 2 spots. If you got rid of that variable, now it's easy. E is just a number, 2.718. Just subtract it. Okay, and I'm done. If you got rid of that variable, this is also easy to solve because I could just change it from log form to exponential, okay? Or exponential to log form. But the problem is I have an x in both spots. So that's something we can't solve easily by hand, and even in my pre-calculus class I don't explain how to solve that by hand. Yeah, but there's a different way we can solve it. Okay, if I basically think of each side of this equation as a picture. Okay. Watch what I can do. So I'm going to type in the left-hand side on one of these lines here. X plus e to the x. Okay, and I'm going to type in the right-hand side on a different line. So if I think of these as pictures, I'm trying to think where this picture equals that picture. But what does that mean visually if 2 pictures are equal to each other? They're the same? What's a simpler way of saying that? That's kind of weird. You normally don't, we say numbers are equal. We don't say pictures are equal. We say it's where the 2 pictures would do what? Intersect, where they cross each other. So if I can draw this picture, and see where they cross, then it'll tell me exactly what the answer is. Okay, so that's the picture on the left. Kind of looks like a horizontal line for a little bit, but then it curves. Okay, and that's the picture on the right. So I can see there's a spot where these 2 graphs cross each other. And this calculator can automatically calculate where things intersect. If I just choose to intersect, I hit enter, and it tells me the answer is 0.44. So is there a way to do it by hand if the calculator can do it? Of course, yeah. If the calculator can figure it out, then there's a way to do it. But it's beyond something that we'd learn in trig, and even beyond pre-cal, maybe calculus. Right? But graphing makes it so even someone in Algebra 1 can figure it out. Just use a graphing calculator. Okay, so I won't expect you to solve one of these by hand, but I might ask you, how could you solve this besides using algebra? And you could say you could use a graphing calculator and explain what I just did. Draw the 2 graphs and see where they cross. In fact, I could use this approach for every problem that I've done today so far. I could draw the 2 pictures and see where they cross. But on tomorrow's test, you won't be using graphing calculators. Any question on that one? Okay, any questions on anything that we've done today? Those are the different types of problems you could see on the test. Okay. Bless you. So on page 490, okay, the homework is 1 to 3 all, 5, 6, 9. And 17 to 21, just the odds.